Okay, now let's take a look at the dot or scalar product step by step. Since you know that the formula for dot product is a dot b is equal to a times b, magnitude of a times magnitude of b times cos of theta. This theta is the angle between vector a and b. Okay, now let us consider we have two vectors a and b in this form, in the coordinates forms or components. So ax is the x component, ay is the y, and component az is along z-axis. Similarly, vector b has these values. These are also called as coordinates: b coordinate, x coordinate, y coordinate, and z coordinate. So if we are given vectors in this form, then we can have their dot product like this. So we write them like this: a vector a dot vector b like this. Then we'll follow the normal multiplication routine that we do with brackets. If we have three components in one bracket and three in another, so we multiply each with each one of the other bracket like this. So first we are multiplying this with this, then this with this, and then with this. So we are multiplying it in a usual way. We get this form. Okay, so there is no need to explain, you know how the multiplication works. So the thing that we need to be explained comes here. Now ax and bx are scalar quantities because these are numbers, and j, and k, all these are unit vectors, or means they're vectors. So scalars will be multiplied as scalars like numbers, 3 times 2 or 2 times 5 or 5 times 6, just like that, and the vectors will be multiplied with dot product like this. So a times ax times bx here, and I dot I, these two. So we will separate them to make it easier for us to easier and simpler for us to calculate them. Okay, so we will do for all of these terms like this. We will separate out with the vectors with dot in between them. So all ax, bx, ay, by, and az, bz, all of these are scalar terms, and we can multiply them as scalars. But all the unit vectors will be separated out with the as dot products. Okay, now let's first see how we can find the dot product of. Okay, here it is. So our formula will remain same. We'll just replace these vectors with unit vectors like this. So let us consider we have two same vectors, same unit vectors. I with I, the dot product of I with I will be multiplied like this. So first is magnitude of first vector, means magnitude of unit vector, and remember that unit vector has a magnitude of 1 only. Okay, so because they are called as unit vectors because their magnitude is considered as 1. And then the second unit vector is also I, and it will have magnitude of 1. So it is written like this. Since both of these are same vectors, they are pointing in the same direction, means along x-axis, therefore the angle between them is 0 degrees. Okay, and cos of 0 is 1. So 1 times 1 times 1 is equal to 1. Okay, now let's multiply, let's take a dot product between I and j. So unit vector I and unit vector j both will have magnitude of 1. 1 times 1, and the angle between them is 90. You can see here, this is I and this is j, because I is along x-axis and j is along y-axis. The angle between them is 90 degrees, and cos of 90 we know is equal to 0. Therefore the dot product of I and j, or dissimilar vectors, or the vectors which are perpendicular to each other, will have a dot product equals to 0. Now let us take dot product between I and k. Okay, now we will follow the same procedure. I has magnitude of 1, k has magnitude of 1, and the angle between them is 90 degrees because I is along x-axis and k is along z-axis, and so the angle between them is 90. Therefore we'll also get 0. Now from here we can establish that the dot product between two unit vectors will be equal to 1, and two similar unit vectors will be equal to 1, and two dissimilar unit vectors will be equal to 0. By dissimilar means, here I mean that the unit vectors which are perpendicular to each other. Therefore, we can say that j dot j and k dot k are equal to j dot j and k dot k is equal to 1 because they're similar unit vectors. Their dot product will be equal to 1, and j dot I and j dot k will be equal to 0, and k dot I and k dot j will be equal to 0. Okay, means the dissimilar unit vectors which are perpendicular to each other will yield 0, their dot product will yield 0, and their dot product with each other will be equal to 1. This is specifically for unit vectors. Now we can put these values in our previous equation here, and we will get our result. So these red ones are going to give us 0 because these are perpendicular unit vectors. So I dot j, j dot I, j dot k, k dot I, and k dot j, all these red terms are equal to 0, and all the other terms, this I dot I dot j, this should also be equal to 0 actually, and I dot I, j dot j, and k dot k, all these will be equal to 1. Therefore, we will be left with ax bx, okay, ax bx, and I dot I is equal to 1, and this is 0, this is 0, this is 0, and this is 1, and ay by will be like this here, then 0, then 0, then 0, and then last term az bz times 1. So we are left with ax bx plus ay by plus az bz. So this is the dot product of a and b vector. So if you can memorize this formula, this is very simple. A dot b will be equal to ax bx plus a times by plus a times az times bz. If you remember this formula, you can simply use this formula to calculate dot product between two unit vectors instead of going through all that procedure. Okay. Now, now let us see two vectors, A like in this form and B in this form. From A, we can extract their coordinates ax, bx, and ax, ay, and az, then bx, by, and bz like this. So here ax will be equal to 3.0 and ay will be equal to minus 4.0, and since we do not have any k unit vector, means that our az is equal to 0. And similarly bx is equal to 2.0, by will be equal to 0 because we do not have any j here. Okay, so and 3 corresponds to the z component, so bz will be equal to minus 3.0. Now we use this formula. Simply we multiply ax with bx plus ay with by plus az with bz, and we get our result very quick and fast like this. So this is very simple, right? So we do not need to go through all the procedure that we went before. If we can memorize this formula, this is very simple. Okay,